Welcome to Vision Plus and welcome back to this Singapore Mathematics. We are looking at equation of a circle, and there is a very important concept which is related to a circle. That's why we are looking at tangents to the circle. And we are saying that a tangent to a circle is a line which touches the circle at only one point. And that line that touches the circle at one point, for it to be a tangent, it must make an angle of 90 degrees with the radius of the circle. So this is the illustration. This is the line, but because it is touching the circle at only one single point, and as long as it is a circle, it will always make an angle of 90 degrees with the radius of the circle. Why? Because the radius of the circle is the distance from the center to any point on the circumference. So as long as the tangent is touching the circle at one point on the circumference, then it makes an angle of 90 degrees to the radius, which is drawn from the center to that point. Example 1 says, find the length of the tangent from the given points to the following circles. So we have the circles. For part A, we have this circle, and then we need to find the length of the tangent, which is coming from the point 0, 0. So the solution, part A. Part A, we are given x squared plus y squared plus 4x minus 6y plus 10 equals to 0. This is the equation of the circle. So let us sketch this circle. The circle is in that manner, and then we have a tangent touching the circle at one point. So you can draw it in any way you want. It is a straight line. So they have said that the tangent is from this given point. Okay, assuming this is the point anywhere here, 0, 0. There is no problem if you draw yours from this point of tangency somewhere this side. You can even draw it vertically as long as it's touching the circle at one point. But this one is simpler to visualize. Now, this is the point where the tangent is coming to meet the circle at this point. Now, remember this circle has the center and the radius in that manner. Now, what are the coordinates of the center of this circle? Since we have the equation of the circle, you can get the coordinates. This is the expanded form, and we have seen how we can get the coordinates of the center when we are given the expanded form. Even we can get the radius. So go on and work it out, but the coordinates of center in this case are -2 and 3. Those are the coordinates of the center. What is the radius? The radius in this case is not given, but we can use the equation to find the radius of that circle. Now, we know that C is given as a squared plus b squared minus r squared. Remember, in the general form of the equation of a circle. Please go back and revise. So our C in this case is 10. So we substitute for C, which is 10 equals to A. Here we have got -2 squared plus B. B is negative, B is positive 3 squared minus r squared. So from here, we can get our radius of the circle. So -2 squared plus 3 squared minus 10. So I'm getting the radius as root of 3 units. That is the radius. Now, after getting the radius, it means that this distance here is root of 3 units. That is from the center up to this point on the circumference where the tangent is touching the circle. Now, after getting the radius, remember we are looking for the length of the tangent. That is the distance from here up to where it is coming. This is the length we are looking for. That is the length of the tangent that we are looking for. What can we do now? We have said that the tangent meets the radius and they make an angle of 90 degrees. That means we can apply Pythagoras theorem. We can form a triangle, a right angle triangle. That is by joining the center and the point where the tangent comes. My ruler is not there right now. Let me estimate, assuming the mid there. So we know this distance from here up to here, and we can find the distance from the center up to where the tangent is coming. Then we apply Pythagoras theorem to find the length. So I'm going to call this distance x. That is the distance between the center and the point where the tangent comes. So the distance x is going to be the distance between 2 points. So x, we shall use the formula for getting the distance between 2 points. It is again colliding with the values I have here. So let me use what distance can I use here? Let me use distance, maybe distance k. So that I have here k equals to, this is the formula for getting the length between any 2 points squared. So you come and name your points. You can name this x2, y2, here x1, y1. Then I substitute for them here. What does it give me? x2 have you 0 minus x1 is negative 2 squared plus y2 0 minus y1 3 squared. And then you find the value of k. 0 minus negative 2 squared is 4 plus negative 3 squared 13. So the distance k is root of 13 units. So this side is root of 13 units. Now that we know the distance from here to here and from here to there, then we can apply Pythagoras theorem to find the distance from here up to there. So Pythagoras in some books, in the South Sudan book we have Pythagoras theorem, which I will use in this case. Now we are going to say, because it says that the sum of the squares of two shorter sides equals to the square of the longer side. That means we are looking for this length. So I'm going to keep it as length, so that we say length, but we are squaring it. It's not looking nice. Let me use another letter here. Let me use maybe y, letter y, because we shall not use any y. Or let me use another letter k. Let me use maybe length p. Yeah, let me use p. So that p squared plus radius, which is root of 3 squared, equals to the square of the longest side, which is root of 13 squared. That is Pythagoras theorem. The sum of the squares of two longer sides, the sum of the squares of two shorter sides equals to the square of the longest side. That means we shall have here p squared plus the square root 3, you get 3, equals to the square root 13, you get 13. That means here p squared equals to 10. So p equals to root of 10 units. Therefore, the length, because our p was the length of the tangent, therefore the length of the tangent from point 0, 0 equals to root of 10 units. And this here, and part B says that we are given the equation x squared plus y squared plus 6x plus 10y minus 2 equals to 0. And then this is the point where the tangent is coming. And the question says that we need to find the length of the tangent. So to make our work look easier, to simplify our work, we sketch a circle. When you draw, you say, this is my tangent to the circle. Use a straight line, and it's coming from the point negative 2 and 3. So let me call this point maybe point B, and then this point where it is meeting the circle, let me call it point A. Remember, the circle has the center in the middle and the radius, which is perpendicular to the tangent. This one makes angle of 90 degrees. What are the coordinates of the center? You can get the coordinates of the center from the given equation. So in this case, the coordinates are negative 3 and negative 5. You know how you can find the coordinates of the center when we have the equation. Now we don't have the radius, but we know that C is given by A squared plus B squared minus R squared. What is C? C is negative 2. So negative 2 equals to, what is A? Negative 3 squared plus what is B? Negative 5 squared minus R squared. Then you plug in your values. Negative 3 squared plus negative 5 squared plus 2. So I'm getting R as 6 units. So the radius is 6 units. So this distance is 6 units. Now, how can we find the distance AB, which is the length of the tangent that we are looking for? That is the length of the tangent. So for us to find the distance AB, we need to first get the hypotenuse, which is that line there. Use a ruler to meet the point B. So we need to get, because we have this distance, so we can get the distance from the center. Let me call center C. From the center C, B. So the length of the distance CB, that is this distance here, the length CB is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. That is the distance between 2 points, the center and point B. And then here, this now gives us the square root of, then you come and name the points x1, y1, x2, y2. Then we substitute what is x2, negative 2 minus negative 3 squared plus what is x, what is y2, y2 is 3 minus negative 5 squared, and then you press the calculator to get that distance. Negative 2 minus negative 3 squared plus 3 minus negative 5 squared. So I'm getting CB as root of 65. This is now this distance, root of 65. After getting that distance, now for us to get the length AB, which is the length of the tangent, we need to apply Pythagoras theorem. Pythagoras theorem. The length AB squared plus the length AC squared equals to the length CB squared. So we shall say the length AB squared, let me put it plus AC squared equals to CB squared. Then we substitute what is AB, that is the distance we are looking for, AB squared plus what about AC? AC is 6, which is the radius squared equals to CB. CB is the length root of 65, but the formula says squared. That means we get the calculator. Here now it means that our AB squared become, what is root 65 squared is simply 65 minus 36. So AB now becomes root of 65 minus 36, root of 29. And now this is the length of the tangent. Therefore, length of the tangent from that point, negative 2, 3, is root of 29 units. So this is the solution to